using NO2 first. So now we move on to question 13, okay? Is KOH an acid or a base? So with this might be a relatively short question. But for this one, we have to really understand what it means to, I guess, be even something that's bonded with potassium, okay? If you look at, actually not going to look at that yet. When you actually have the formula, right, for KOH, when it reacts with water, okay? In fact, we don't even actually put it reacting with water. So actually do, when KOH is submerged in water to form an aqueous solution, right, it completely dissociates, as it is just going to be K plus ions and OH ions, okay? So now that we have, this is what actually dissociates into. That is really what KOH does in water, right? Now we look at this part, okay? Because remember the definition of a Bronsted-Lowry base? So potassium, unfortunately, it's really just by itself. It has no valence electrons, so it cannot accept hydrogens, and it has no protons of its own, so it cannot give any hydrogens, okay? But OH minus, if you drew its Lewis dot diagram, I'm just going to do a shorthand. Look at all the possible, remember it's OH minus, right? So the oxygen not only has a reason to try to make sure it gets more positive, but look at all this lone pairs it has. It has this lone pair to attack hydrogen, this and this to attack the proton, I mean, okay? So with that being said, okay, it will kind of just go on. You see there's a proton running about, okay? And remember that the OH minus has that because O only gives 6, hydrogen gives 1, so you need an extra to have 8, which is exactly, there's 8 electrons here. So hydrogen comes in, the OH snatches it, forming H2O, okay? And if you look at the number as well, exactly, so for the first one it was 6 minus 6 plus 2 over 2, so that'd be 6 plus 1, that's 7, so it was -1, hence why it was -1 there. But here now, we've been able to get another electron, so that's another hydrogen bond, which is something it really wants. And also, it would be 6, well, it's not 6, it would be 4 now, plus 4 over 2, okay? So that's actually going to equal 0. So it's gotten another hydrogen bond, and it's been able to resolve its charge, so something that it really wants to do. Hence why water molecules are such a stable and, you know, something that it really likes to be. Water is everywhere and stuff. Because of this, actually. So if we rewrote the formula, it would be OH plus H2O, because that's usually what we use is the person that's going to give hydrogen, okay? So it's going to be written like this. So I just want to make sure this arrow is looking nicer. So OH plus H2O turns into H2O. Oops, that's not H2O. It's H2O liquid. H2O liquid plus OH minus. So really it just switched protons. But if we accounted for the base and conjugate acid, we have the base here, and the conjugate acid would be that one, and this would be the acid because it's now giving, the water's giving that OH the base, OH the proton, and this one becomes the conjugate base. So the reason why I drew it like this is because since KOH dissociates to form OH minus hydroxides, and the hydroxides react with water to, you know, form this, meaning that follows in both examples the Bronsted-Lowry definition of a base, and the K is not doing anything other than just being an ion in the solution. In total, this one makes KOH a base because its constituents, aka specifically the hydroxide, is working as the base in this situation. So exactly. With that being said, It is a base, and I wanted to actually show you this because if you actually scrolled down on our table value, right, OH is considered like one of the strongest bases, like the strongest bases you can have. So KOH would be working as a base because as soon as it produces hydroxide, it's gonna make the solution more basic. Now, in regards to knowing whether it's a strong or a weak base, those ones when formed with hydroxides, it can be a little tricky, just because if I recall, I don't think every metal bonded with hydroxide is as soluble. So depending on the solubility of the actual solid, depending on how it works as a strong or a weak base. So point being though is that when they say it's a base, that is correct. Okay, so KOH is a base because it separates to form K and OH minus, and it's the OH